Hey everybody, Cozy Azeroth, aka Zachary Fruling here. As promised, I am back with another type-in program from the TI-99 4A User's Reference Guide. This time, we are going to do Bouncing Ball. Bouncing Ball. This program moves a ball and bounces it off the edges of the screen. Each time a ball hits any side, a tone sounds and the ball is deflected. The following special character is used to define the ball. So, characters in TI Basic are 8x8, very typical of a sprite, but it's not really technically a sprite, just a user-defined character. And the block codes are defined in hexadecimal here. Hexadecimal, excuse me. These statements clear the screen and define character 96 as the ball. Let's look over the whole program first. Okay, lines 130 to 170. These statements allow you to input the color of the ball and the screen background color. Note that defining the screen color by using character set 1, which includes character 32, the blank space, gives definite limits for the screen edge. The screen is cleared when the colors have been entered. Okay, lines 180 through 210. These statements give the starting position for the ball and set the parameters which will control the X and Y direction, right? Either positive or negative. Okay, 220 and 230. These statements compute the next ball position. The direction the ball moves depends on the current values of XDIR. +1 indicates right, -1 indicates left, and YDIR. +1 indicates up, -1 indicates down. Lines 240 to 270. These statements test to see if the new ball position is still on the screen. If either the row or column value is out of range, then the program transfers to line 310, column out of range, or line 360, row out of range, to change the ball direction. Okay, lines 280 through 300. If the new ball position is still on the screen, then the screen is cleared to erase the old ball location. The ball is then displayed at the new location designated by Y and X. Okay, lines 310 through 350. These statements change the direction of the ball as if X is out of range. The call sound statement produces the bouncing tone. Lines 330 and 340 check to see if Y is also out of range. If it is, the program transfers to change the Y direction. If not, the program transfers to line 220 to compute a new ball position. And lines 360 through 380, these statements change the direction of the ball if Y is out of range. The call sound statement produces the bouncing tone. The program then transfers to line 220 to compute the new ball position. So this is a pretty straightforward program. Let's get busy typing it in. Bouncing ball, here we come. Let's get into TI Basic. Okay, we're starting, for some reason we're starting with line 100. Remark, bouncing ball. Bouncing ball. Line 110, call clear. Clears the screen. Okay, here's where we have to be a little careful. We have to define a character. Call CHAR. Okay, we're defining it as character number 96. And we are going to use this string, which we're going to type in very carefully here. 3C7E. 3C7E, because I only want to type this once. Okay, then we have 6 Fs, FFF, FFF. Okay, then we have FF, FF, 7E, 3C. 7E, 3C, I can remember that. 7E, C3. And the quotes, and the parentheses. 7E, 3C. Did I get that right? I did. Okay, line 130. Input ball color. And I think let's do it exactly as it's written here. Question mark with a space. And we are going to call this, what, probably C for color? Yeah. Colon C. Numeric variable C. Okay, line 140, input screen color, same thing, and we're going to call that S. Input screen color, colon S. Okay, 150 clears the screen again. Oops, call clear. 160. Call color. These are going to define the colors for looks like character group 9 and character group 1. Nine comma C comma S. 170. Call color 1 comma S comma S. 1 comma S comma S. 180. Okay, X equals 16. $190, Y equals 12. $200. XDIR equals 1. $210. YDIR equals 1. Okay, $220. X equals X plus XDIR. $230. Same thing with Y. Y equals Y plus YDIR. $240. If X is less than 1, then 310. 250. If X is greater than 32, then 310. Okay, 260. If Y is less than 1, I believe, then 360. 270. If Y is greater than, I think, 24, if memory serves, yep, then 360. Okay, 280, call clear, clear the screen. $290, call HCHAR. So it actually draws the ball to the screen. HCHAR. Y, row, it says row and column. Y comma X comma 96. It's interesting because in modern programming languages, these are often reversed. You get the X position and the Y position, not row and column. I see why they did it this way because people are used to rows and columns, but in this system it does it Y comma X. Okay, and then 300 go to 220. 310. Here's where we're changing the X direction. XDIR equals negative XDIR. Make sure I got that right. Yep. 320. I think that was a call sound statement. 30, 380, and 2. 30, 380, comma 2. So this is 30 milliseconds. The frequency is 380, and this is the volume level 2. That's the syntax for a call sound statement. 330. If Y is less than 1, then 360. And if Y is greater than 24. Y is greater than 24, then 360. 350, go to 220. Okay, we're going to do the same thing with the Y direction now, 360. Y direction equals negative Y direction. Change the direction of the ball is traveling in the Y axis. 370. Same thing, call sound. 30, 380, comma 2. And 380, go to 220. Okay. Well, we're pretty much done. 380, go to 220. Let's clear the screen and let's list the program. And we're just going to casually skimming this to see if there are any syntax errors. Looks pretty good so far. Pretty basic. Let's run the program. Okay, ball color. Oh, I don't know. How about a yellow ball on a magenta background? So something like 12 and 14. Yeah, there we go. Oop, I made a mistake with the ball. That ball does not look right. What did I type in wrong here? Okay. Let's list out the program. It's line 120. So I made a typo there somewhere. So list 120. Let's go back up here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 11, 12, 13, 14. Okay, I must have a typo in there. 3C, 7E, 3C, 7E, FF, FF, wait, 1, 2, 3, 4, 5, 6, and we have FF, 7E, oh, there it is, I got a typo, 120, let's retype it, call CHAR 96, how did I mess that up? It's, you know, a little dyslexia, not really, but 3C, 7E, FF, 7E, 3C, yep, 7E, 3C, I got it backwards, 7E, let's be really careful, 3C, see the difference there? And that should fix it. Let's clear the screen, let's list out the program. Okay, let's run it. Let's do the same thing now. Let's do a yellow and magenta. That's a pretty color combo right there. Let's get a few screenshots of this. I just want to peek at my screenshots, make sure I got my... Oh yeah, we got something there. We're good. All right, there's our bouncing ball. Check it out. Let's do a few other color combos, because that's all we can vary in this program. Let's run it again. Okay, ball color. How about white on dark green? So white on. There we go. That's a happy color combo. Reminiscent of Burlington Northern. The flickering is because of the screen clearing. It doesn't move smoothly, and there are various ways to do that. In Extended Basic we have sprites, but we're in regular TI Basic, not Extended Basic. Okay, let's try another color combo. What would look good? How about a, oh, I don't know, a red ball, like number, I think 7 is a red, on some sort of a blue background. There we go. You know, it's similar to Pong in a way, except Pong is randomized a little bit. So, you know, as the ball bounces, there's a unpredictability in the angle that it comes off at. So we could program that in as well. But maybe I'll do another video of customizing this program. Okay, let's see what other colors we can do here. How about, I don't know, a green ball. How about the same light green color on a gray background? There we go. Not the most exciting color scheme. Not enough contrast. It doesn't look very good, does it? Of course, it's, you know, following the same pattern every time. You know, we could introduce some randomness into the starting position as well. That would be interesting. Okay, ball color. Oh, I don't know. How about a black ball on a white background? And maybe, how about a magenta ball on, oh, what would look good? I don't know. On a black background? Yeah, there you go. That looks pretty good. Okay. A lot of contrast. Okay. So I'm just grabbing a few screenshots while I'm at it. I like to get a couple screenshots for the YouTube thumbnails. Let's see. So we tried black, red, yellow, not really an orange, green. Let's do like a dark green ball this time on, oh, I don't know. How about a red background? I think very Christmassy. It's not the coolest color combo. Okay. Run. Ball color. Let's see here. How about gray? Oops, excuse me. Screen color. I accidentally hit enter twice. Ball color 15 on, what, a yellow background. Yeah, it's not enough contrast. You can't really see it very well. But you know what might look good? Like a black on a yellow. Like a light yellow. Looks good. There's a lot of contrast there. But I think, in reality, the one I chose right at the beginning was probably the coolest, which was a yellow ball, right? I think it was 12, I think, on magenta. Oh yeah, see, I think that's nice. Nice, happy color scheme, lots of contrast. Let's get a couple screenshots of that. Unfortunately, I got to do it a couple times because it might be, I'm probably taking a couple of screenshots while the ball's not on the screen. So, anyways, you know what we could try to do? We could try to randomize the starting position. That would be fun. I think we have time to do that. Let's end the program and let's list it out. So what we need to do, those initial starting positions, 180 and 190, we need to make those random if we want to change the starting position of the ball. So what we want to do is, I think x equals int of RND times, let's see, on the columns, we have 32 columns, so 32 plus 1. I think that'll work. And on line 190, we can do y equals int RND times 24, that's 24 rows plus 1. I think that will randomize the position of the ball, but we need to add let's list out the program one more time. We need to add a randomized statement. So let's add a line 105. That'll make sure that every time the program is run, it uses a new randomization seed. So 105 randomize. We'll list out the program one more time. There's our new randomize statement. And then when these random numbers are generated, you know what I could do actually, just to make extra sure that we get new positions every time. Let's delete line 105. Let's list out the program again. We can put a randomize statement before each of these two randomization random number generators. That way, that every single time a new x, new y, and they don't always go together. So let's do. Let's see, where are we here? Right before 180, so line 175 randomize, and then right before 190, so 185 randomize. There we go. Let's clear the screen. List out the program. That way, when the x coordinate and the y coordinate are generated, it will generate them completely from scratch separately. So let's see, how does this work? Ball color. Let's do the same color scheme we've been using. Let's do 11 and magenta for the screen color. Yep, the ball was over there on the left. Did you see that, bottom left? Okay. And now if we break the program and run it again, same thing, 11, 14. So let's see, we should get a totally different starting area now. Okay, it was similar, but different, I think. Let's just check our theory here. It was a little too similar to know. We're looking for a starting area in a completely different part of the screen here. Oh yeah, so it started in the top left this time. So that worked pretty well. Hit exactly in the corner. Did you see that? Okay, let's run it again. Let's mix up the colors just for fun. How about a black ball on a white background? There we go. It started in the bottom right. Did you see that? So pretty easy to randomize stuff in TI Basic. Okay, let's see what else we could do. We could randomize the angle. I need to kind of remind myself how to do this. But we have the user's reference guide open. So on lines, let's see. So x direction equals 1, y direction equals 1. And that's making sure that when we change the x and y position, it's changing them according to whole numbers. And then when we loop back, we go to line 220. I'm wondering if we could use a random number generator to, when we're increasing the x and y value, we could actually, let's see, I'm trying to think how I'd want to do this. We could use a random number generator between you know, maybe between, I don't know, 0.5 and 1. We'll give it a little bit of variation. Not really sure. Where does it change direction? It's down on lines 310 and lines 360. So we could, let me think. We could vary the, I think we need to change XDIR. So let's just try it. I mean, we can always go back, right? And if I screw it up, then we just end the stream and call it a day. It's fine. No harm. So XDIR, well, let's randomize. So 200 randomize, and then 205. XDIR equals, now here we're going to do R in D. I think R in D, if memory serves, let's go to the user's reference guide. We want to look up, let's just make this a little smaller so I can skim a little more easily. I'll find it here. R&D, section 2, page 96. Okay, let's find out exactly how this works here. Right by it. Okay, random number. Okay, yeah, so it generates a random number between 0 and 1. That's kind of what we want, right? Although it might be just a little too, it could potentially be very, very slow, but that's okay. Let's just see how it goes. So 210, we'll randomize again. And then 215, we'll have YDIR equals RND. And then, yeah, but that way when we get two lines, 220 and 230, those can stay the same. I think this should vary the X and Y speed. Let's see how it goes. Maybe I screwed it up. Oh, yeah. So look, it's moving. It's weird because it has to fit the ball into a grid slot, right? So it is working, but it's rounding to the nearest grid slot. So if you look, it's going like over 2 and up 1. And if we run it again, it should now work at totally different angles. Yeah, so see now, look, it's bouncing more vertically. Check it out. So we did manage to randomize the angle of the ball's trajectory. Let's see if we can get some extreme cases here. That one's looking a little more even. I'd like to see an extreme case of what we did, but it's up to the random number generator what we get. So this one's moving slowly to the right. So if you look, this angle's pretty sharp, but when it bounces off the top or bottom of the screen, the angle's not very sharp. That worked pretty well. I'm actually pleased that I got that working as well as I did. And we could, of course, randomize the angle that it comes off at, make it more Pong-like. That would be interesting. I guess if we wanted to do that, let's list out the program. So when we loop the program back to... Right now the program is looping back to 220. It's a little more complicated because we'd want to put some parameters on it. Like, you don't want to bounce at some wackadoodle angle. But we could do that. We could make a loop at a wackadoodle angle. I think what we'd want to do, if we were going to do that, I like the way it's working. Let's see what happens if we, here where we have line 310, let's have xdir equals negative RND. Okay. And then on line 360, y dir equals negative RND. So this should vary. Every time we bounce, we should change the angle now, I believe. I think. Oops, run. I think that's how it's going to work. But if we get any weird behavior, either we'll fix it or we'll give up hope. So we're moving, we're moving, we're moving. Now when we bounce, we should change angles. Boom. Okay, did that work? It's a little subtle. It's hard to tell. No, we ended up with a problem here. We're stuck. What happened? It might be too small. Let's... That looks pretty good. That looks pretty good. Okay, the angle changed. And it gets stuck. Why does it get stuck? I think it might be because it's rounding and gets stuck. Right now we're going back to... You know what we could do? I think it's just the value is so small that it's rounding down and it's getting stuck. But that's okay. We got it to work. You know, I might want to work on this program a little more and see if I can make an even more sophisticated bouncing ball program. Anyways, that was Bouncing Ball from the TI-99 4A User's Reference Guide. Be sure to check out my YouTube channel. You can find me either under Cozy Azeroth or Zachary Fruhling, either one, for lots of TI-99 4A content, along with some other content, some retro programming, some World of Warcraft, some retro gaming, various other modern games. I'm streaming all kinds of things. And if you're watching this live on Twitch, I see someone watching. Thank you for tuning in, whoever you are. Be sure to check out my YouTube channel as well, and I think I'll come back in a little bit and do some WoW Classic hardcore for a little bit. I got a little bit of time to kill, so I'm going to do that, and then I may or may not be back for some regular World of Warcraft later if you're watching this live. Hope everyone's having a good evening so far, and thank you for tuning in. I'll be back with the rest of these User's Reference Guide type-in programs soon. The one I'm really excited about is Graphics Match, which is a little simple slot machine game, one of my favorite type-in programs from when I was a kid. Still think it's fun, still think it's cute, so we'll get to that at some point, but I'm going to run through all of the type-in programs first before we get to that. Anyways, I will be back soon. Thank you for watching. Have a great afternoon.